Hello, my friends. Happy Monday. I hope your weekend was wonderful and restful and full of all the things that you love. I hope Mrs. Thompson is there with you, and I hope you understand how lucky we are to have her in our classroom. For all you Lake and Cottage Grove newbies, she is honestly the best substitute that you might ever have. So give her a warm welcome, be super kind, be helpful, and please work hard. I will be back tomorrow on Tuesday. If you haven't done so already, you should pick up a new bell ringer and please turn in your old one. Double check that your name's at the top. And with your new bell ringer, get your name at the top, your hour, and please put the week of November 12th through the 16th. Mrs. Thompson, if you want to choose one lucky winner after they've turned in their bell ringers, usually I pick one random bell ringer, and if it's all filled out correctly and they have all of their I can statements and they have their name and the week of, and it looks like they did everything that they should have done on their bell ringer, then I give them a piece of candy. So if you want to do that, go right ahead. If not, I can do it when I get back tomorrow. You're going to need out a pencil today, your bell ringer, and since we just finished Unit 2, Part 1, you're not going to need that out right now. Keep it in your binder. We will file it away when I return. The 3 bell ringer questions are up on the screen. I want to know one high and one low from your weekend. I want you to draw an emoji to show how you feel today. And then I want you to use the final box to answer the questions from the next slide. So Mrs. Thompson will give you a minute or two to get your I can statement written, get your bell ringer filled out with numbers 1 and 2, and then she'll switch to the next slide so that you can have a little number talk. Go ahead and pause this video, Mrs. Thompson, until everyone's ready to go. All right, my friends, this is your opportunity to show Mrs. Thompson what incredible mathematicians you are, how you notice and wonder things, how you come up with these beautiful noticings and really impressive ways to explain the math that you see. So I want you to write down at least 2 things that you notice and at least 2 things that you wonder from this chart or map or graph or whatever you want to call it. This is straight from CNBC, or the source is the United States Election Project, and this is regarding the recent midterm election. Pause the video, take a few minutes to write down what do you notice and what do you wonder. All right, Mrs. Thompson, you're welcome to use the name sticks that I have on the middle front table to just call on people to share what they notice and what they wonder. And I bet you, Mrs. Thompson, have lots of great things to add as well. Go Minnesota! All right, now the real math. Minnesota has an estimated 4,064,389 residents who are eligible to vote. Using the data from the previous slide, how many people voted in the midterm election? That slide showed us that there were 64.2%. I need some brave volunteer to show us how to do this. 82% of the voters were registered before Tuesday's election. How many people were not registered ahead of time? Not what percentage, how many actual people were not registered ahead of time and had to do same day voter registration. Take some time to work this out. You can work together, you can work it out as a class, whatever Mrs. Thompson wants you to do. But this is just to get you thinking about math and how it applies to real life. Pause the video until you're done, and then we'll move on to the lesson. Just another interesting graph. Any history buffs know what was going on around this time? Yeah, me neither. All right, let's talk math. If you haven't done so, pick up a new packet. This is Unit 2, Part 2, Solving Multi-Step Inequalities. So you're just going to kind of pick up from where we left off. This lesson's going to go pretty quick, if I had to guess, because you guys are rock stars and This is not all new. There's kind of just one new piece that we're adding on. So once you have your new packet, open up to the first page, get your name written at the top, please. Today's date is November 12th. The topic is solving multi-step inequalities, and the class is your hour. Not a lot of notes to take today, but the new information is listed is written at the top of your notes, and that is what is called interval notation. So interval notation is just another way, kind of a fancy way, of expressing the answer to an inequality. We are used to graphing the solution set on the number line because it would be a big pain to have to write out all the possible solutions when we graph an inequality. So typically we use a number line. But another way to show what the answer to an inequality problem is to write it in interval notation. And this typically takes kids a day or two to really understand or become comfortable with this kind of notation because it's just not something that we're used to. So what you're going to need to know is whether or not you should be using a parenthesis or a bracket. Don't worry, you don't have to draw any fancy braces. We're just sticking with parentheses and brackets for interval notation. Which symbol you use is dependent on whether or not there's an open circle or a closed circle in your inequality. And what you're going to find is that we always use parentheses with infinity or negative infinity. Yeah, did you know negative infinity was actually a thing? Probably not something you've talked a lot about, but when we solve an inequality and shade it to the left, when x is less than or equal to something, that actually goes on infinitely to the left. So through all the negative numbers, and if we kept going forever and ever and ever to the left on that graph, eventually we'd arrive at negative infinity. So the solving part of this lesson is no different from what we've done. And there's one really important piece to remember, and that is when you are operating with an inequality, anytime you multiply or divide by a negative number, what do you got to do to the symbol? You got to flip it. When we make something the opposite through multiplication or through division, we have to flip the symbol to make sure that our solution set or our statement is true. So a quick review for solving multi-step inequalities. Step 1, distribute if necessary. Step 2, combine like terms when you can. Step 3, move the variables to the same side, the constants to the other side. Step 4, isolate the variable or solve for x. When you've completed solving number 1, please graph it on the number line. You may want to stop for a quick discussion on how you can tell whether to put an open circle or closed circle, or you could check in with the person sitting next to you to just make sure you're on the right track with that. I'm going to give you a minute to solve number 1, and then we'll talk about interval notation. All right, so solving number 1. This is probably going to seem super simple to you because you guys just got done testing on crazy solving of equations. So hopefully this is what you got. X is greater than negative 9. Graphed on the number line. Open circle at negative 9 because it doesn't include negative 9. So it's everything greater than negative 9 up to negative 9. Shaded to the right. Remember, if the variable's on the left, this symbol points in the direction to which you shade. And interval notation is what's new. So for interval notation, we're basically just writing the range of what our graph shows. And so this graph shows that the least it's going to ever be is every number up to negative 9. So we use negative 9 as our starting point for the least value or the least amount. Shading to the right, eventually we would get to positive infinity. And so we use infinity to show the range on the opposite end, so the greatest value that x could be. And how I chose to use parentheses, how I decided that parentheses were the right symbol to use, was based on this chart up here. Parentheses get used when not included or when there's an open circle. So anytime a graph starts or ends on an open circle, we use parentheses. Since -9 is at an open circle because of this symbol, I use parenthesis at -9. And since we can't actually ever physically insert the value of infinity into an inequality, we can do everything up to infinity, the largest numbers, but infinity isn't an actual value that we can plug in or substitute into this inequality, so it's technically not included in our solution set, but everything up to infinity is, which is why we use a parenthesis for infinity or for negative infinity, no matter what. I'm going to give you a couple of seconds to try the next 3 examples. So I want you to, with a partner or on your own, take a minute to do numbers 2, 3, and 4. Graph them on the number line, and then try interval notation. If you are totally lost, which many of you likely are, Mrs. Thompson can walk through those examples with you, or you can talk to a partner about it. To check your thinking with mine, I'm going to leave this up here so that you can take a peek. Lots of negatives that I'm going to make sure you're using precision with. So far we haven't operated in terms of, until we get to number 4, multiplying or dividing by a negative number. That's the first time we see or we recall that we need to flip the symbol from less than or equal to greater than or equal to. Interval notation, like I said, it takes a while to get the hang of it. You're writing the range. So what does this graph show? This shows all numbers from negative infinity, because this is going to go on forever. So our smallest value is negative infinity, and our greatest is -5, not including -5 and not including infinity, which is why we use parentheses. Number 3 is our first example where -2 is actually included as one of the solutions. And so still we're shading to the left, which means negative infinity is going to be the smallest value we ever get to. And -2 will be the greatest. We use a bracket to show that -2 is included as part of the solution set. Here's number 4. All right, I want you to cruise through the next, not cruise through, take your time with 5 through 7. Check in with Mrs. Thompson or with somebody next to you. And then as soon as she feels comfortable or you feel comfortable or however you guys want to decide that, homework number 1 is what you're working on. Mrs. Thompson, what I would do if I were you is make them all do number 10 to show you how awesome they are at distributing with a negative. But this is probably one of the trickiest one on this on the set of examples. So I would say if you can do number 10, you're likely ready to move on to the homework. Your homework is homework number 1. I don't mind if you listen to music while you work, but that's something that you'll need to check in with Mrs. Thompson about to see if she's okay with before you start. I hope your day is wonderful. I hope you get out of here with no homework or with little homework, and I look forward to seeing you tomorrow. Have a good one, you guys.